Forget everything you thought you knew about our solar system's neighborhood. For decades, we've been staring at the dusty, frozen deserts of Mars, convinced that if life exists, it's hiding under a red rock. But what if we've been looking in the completely wrong direction? What if the real biological frontier isn't a desert, but a hellish, acidic, swirling nightmare of clouds? Scientists just found something in the atmosphere of Venus that shouldn't be there, and it's changing everything we thought we knew about the planet next door. Welcome to Sci Nova. Today, we are diving deep into the clouds of Venus to discuss a discovery that has sent the scientific community into a heated, high-stakes debate. We aren't talking about finding a little green man in a spaceship. We're talking about something much more subtle and much more profound. We're talking about chemical fingerprints. A single, impossible gas has been detected in the Venusian atmosphere, and it's acting like a biological smoking gun. Is it just a weird chemical quirk? Or are we looking at the first evidence of aerial life? To understand why everyone is freaking out, we first have to understand what Venus actually looks like. On the surface, it is a literal hellscape. The atmosphere is composed of approximately 96.5% carbon dioxide and 3.5% nitrogen, creating a crushing greenhouse effect that makes the surface hot enough to melt lead. It is a thick, toxic soup of acid and heat. If you stood on the surface, you wouldn't just die. You would be crushed and evaporated almost instantly. It's the last place on Earth anyone would look for a biological oasis. But as with most things in space, the story changes once you move away from the ground. While the surface is a death trap, there is a specific layer in the upper atmosphere where the temperature and pressure are surprisingly Earth-like. It's a temperate zone, floating high above the crushing surface, nestled within the thick cloud decks. This is where the mystery begins. This is where the chemical signatures that shouldn't exist were first spotted by researchers back in 2020. In 2020, a team led by Professor Jane Greaves published a bombshell paper in the journal Nature Astronomy. They reported the tentative discovery of phosphine, or pH3, in the cloud decks of Venus. Now, for those of you who aren't organic chemists, phosphine is a gas that is incredibly difficult to produce through standard geological or lightning-based processes on a rocky planet. On Earth, phosphine is almost exclusively associated with life, specifically anaerobic bacteria that live in oxygen-poor environments. Finding it on Venus was like finding a footprint in a place where no one should be walking. Now, I know what you're thinking. Is this just a mistake? Science is often a process of being wrong until you're right. When the 2020 report first dropped, the skepticism was immediate and massive. Critics argued that the signal might have been noise or an error in the data processing. However, the story didn't end there. Since that initial report, the detection of phosphine has been supported by independent analysis of archival data from various planetary probes. This wasn't just a one-off fluke. Multiple eyes looking at the same old data are seeing the same strange signal. But the mystery has only grown more complex. It's not just the phosphine. Recent scientific speculation has also pointed to the presence of ammonia in those same cloud decks. When you combine phosphine and ammonia, you start to see a pattern of chemicals that are highly reactive and often linked to biological processes. On Earth, these chemicals are part of the complex dance of life. On Venus, they are floating in a sea of sulfuric acid. It's a chemical puzzle that currently has no easy solution, and that is exactly what makes it so exciting. Let's take a step back and look at the why. Why would life exist there? If we imagine life not as creatures with lungs and skin, but as microscopic organisms, single-celled microbes, the Venusian clouds become a very different place. These microbes wouldn't need to breathe oxygen. They could potentially thrive on the chemical gradients present in the clouds. They wouldn't be crushed by the pressure because they would be floating, much like plankton in Earth's oceans. We are talking about an aerial biosphere suspended in the sky. Of course, we have to address the elephant in the room, the non-biological explanation. Skeptics argue that we might just be missing something about Venusian chemistry. Perhaps there is some unknown high-pressure geological process occurring deep below the surface that pumps these gases up into the atmosphere? Or maybe some strange interaction between sunlight and the sulfur compounds creates these gases through photochemistry. It is entirely possible that we are seeing a complex, non-living chemical cycle that we simply don't understand yet. But until we find that missing link process, the biological hypothesis remains on the table. The tension in the scientific community is palpable. On one side, you have the astrobiologists, who see the phosphine as a beacon of hope, a sign that life is more resilient and common than we ever dreamed. On the other side, you have the geochemists who believe we are simply being blinded by our own desire to find neighbors. This isn't just a debate about a single gas, it's a debate about how we define life and how we interpret the signals from the cosmos. It is a beautiful, messy, and essential part of the scientific method. So, what happens next? We can't just keep looking at old data and guessing. We need new eyes on the ground. Or rather, in the clouds. This is where NASA steps in with its heavy hitters. One of the most anticipated upcoming missions is the Da Vinci mission. This isn't just a flyby. Da Vinci is designed to actually descend into the Venusian atmosphere. It will act like a sophisticated probe, studying the atmosphere from the temperate cloud decks all the way down to the crushing surface, gathering much more precise data than we've ever had before. Da Vinci will be able to measure the exact concentrations of these gases with unprecedented accuracy. It will look for the specific isotopic signatures that distinguished biological production from geological production. If the phosphine is there, and if it's being produced by something living, Da Vinci could be the mission that finally confirms it. We are standing on the precipice of one of the greatest discoveries in human history. The next few years of Venusian exploration will likely define our understanding of our place in the universe. Think about the implications for a moment. If life is found in the toxic acidic clouds of Venus, it means life is incredibly robust. It means life doesn't need a perfect Earth-like garden to thrive. It just needs a chemical gradient and a little bit of energy. It would mean that across the galaxy, in the atmospheres of gas giants and the clouds of rogue planets, life might be happening all around us, in places we previously dismissed as dead zones. The universe just got a lot more crowded. Venus is no longer just a bright light in our night sky or a cautionary tale of a runaway greenhouse effect. It is a frontier. It is a mystery waiting to be solved. Whether it's a biological oasis or just a very strange chemical laboratory, the clouds of Venus are teaching us that the universe is far more complex and far more surprising than our textbooks suggest. We've been looking at the stars, but perhaps we should have been looking at our neighbors all along. Thanks for watching this deep dive into the mysteries of Venus. If you found this journey through the clouds as fascinating as we did, make sure to hit that like button and subscribe to SciNova. We're constantly exploring the weird, the wonderful, and the impossible parts of our universe. And we'd love to have you along for the ride. Let us know in the comments. Do you think there's life in the clouds? Or is it just chemistry? We'll see you in the next one.